Okay, 24 and 25 are together as well. The following is a sample of 5 matched pairs. These pairs are matched with each other. Matched pairs. Now when you see that term matched pairs, that means these samples are dependent. Because they're matched, one sample is literally matched with the other. Each sample has to do with the other. This number affects this number. They're paired with each other. They're not paired with any others. They're paired with that particular value. On our formula sheet, we have here, this is what we're looking at, t-test for comparing two means for dependent samples. It's the only test formula we have for dependent samples. We have a confidence interval for the means of the difference of dependent samples, but we're not talking about that here. We're talking about a t-test. There's two components. There's the t value, and there's the standard deviation here that we can also calculate. Now, this d stands for difference. So in the standard deviation of the differences, it's got some stuff with the differences in there. For the t, the differences, it tells you this d bar is the average of the differences, the sum of the differences divided by the number of values. Subtract the mean, the population mean of the differences, divided by the standard deviation of the differences, which is here, divided by the square root of n. Now, this calculation is very tedious if you're doing this out by hand, even with a calculator. If you simply find the mean, then the standard deviation, and find the t-value with the calculator, it makes your life much more easy, but I'll show it both ways. So first, let's write this formula down. And that's what we're calculating here, actually, the test statistic. So the formula is the average of the d's minus the mean, minus the population mean of the differences, divided by the standard deviation of the differences, sample standard deviation of the differences, divided by n. And I believe that's the square root of n, shouldn't it be? Yep. And the standard deviation of the differences is a whole other formula in itself. Well, let's say the average of the differences is the sum of the differences divided by n. Standard deviation of the differences is let me write that a little bit better than that. I think that's what we have there. Yep. Okay, so let's try to situate this. So, okay, so I'm calculating, it's not a nice color, calculating t, the test statistic, that's what I have to calculate here. It might help if I calculate this first, so maybe I'll do that. Okay, let me append this table here. How do I want to do this? So let's calculate the differences. The difference here, 19 minus 25 is negative 6. Here it's negative 2. Here it's negative 13. Here it's 7. And here it's negative 4. Those are my differences, right? So those are my d values. So let's make a little table here, a short one. Negative 6, negative 2, negative 13, 7, and negative 4. In this formula, I need the differences squared. So 36, 4, 13 squared is 169, 49, 16. So I need the sum of the differences for this, and I need the sum of the differences squared for this. So I need the sums of each of these columns. That's a 4 there. I could do it by hand, but why not just, use this silly thing here. -6 plus -2 plus -13 plus 7 plus -4 plus -4 -18. Does that seem right? Yeah, that seems right. It's the sum. And then, let's say 36 plus 4 is 40, plus 169, plus 49, plus 16, 274. Okay. Okay. So now let's try to calculate here. I've got five pairs. That's my n. 5 times the sum of the d squareds. 5 times 274 minus the sum of d squared minus -18 squared over 5 times 4. I can put this all in the calculator here, but I know these calculations can be weird. So let's say 1370 minus, this is going to be over 20, right? Minus 324 over 20. So 1370 minus 324, that should be 1046 over 20. You can do that all in one. Square root of 1046 divided by 20. Oh, it's in the calculator here. 7.2319. That's SD. Okay, 7.2319. Excuse me. I'm going to go to the side here. So I still have this T formula. The average of the D's minus the mean D divided by SD over the square root of N. I think that's the right formula. Yes, yes, yes. Okay, so the average of the D's is the sum of the D divided by N, which is -18 divided by 5. -18 divided by 5. -3.6. -3.6 minus the mean of the differences. The null hypothesis is that is equal to 0. So that's 0 minus 0 over 7.2319 divided by the square root of 5. So -3.6 divided by, let's see what that denominator is, 7.2319 divided by square root of 5. 3.2342. So -3.6 divided by 3.2342, -1.13. And that's our T. -1.113. Sorry. Now we could have done this a little differently by using the calculator. So here's how we could have done that. So let's say I go to well, let's clear this second memory. 4 is clear all lists. Enter. Okay. So stat edit. And what I'm going to enter are the differences, because all of this is based on the differences. So let's enter the differences. -6, -2, -13, 7, -4. Those are my differences, right? So now I go to stat. I'm going to calculate one variable statistics. The mean, the sample mean of those differences, d bar is -3.6. It's -3.6. We know the mean of the differences is 0 because that's assumed. Divided by the sample standard deviation of the differences, 7.2319. 7.2319. Divided by the square root of n, square root of 5. So we're here already just by inputting the differences into the calculator and running those statistics. We skip all of this cumbersome calculation. Oops, drop my pen. You skip all this cumbersome calculation by just entering the differences in here. Going to calculate one variable statistics, and we have the mean of the differences. Just imagine that's the D. The sample mean of the differences and the sample standard deviation of the differences here, which are the two components that we need for that formula. In the next example, I'm going to use the calculator. I'm not going to do this calculation all over again for number 25. Okay? Okay, 25. Again, we've got 5 matched pairs. Matched pairs, matched pairs, matched pairs. Use a different color. So we know this is dependent. These samples are dependent on one another. So we want to do the hypothesis test using the same kind of method we used before. No hypothesis. The mean of the differences is 0. There's no difference between the mean differences here. And the alternative hypothesis is the mean of the differences, the actual population mean of the differences is greater than 0. That's what we're testing. So if I go back and look at the steps of hypothesis testing, the traditional method: state the hypotheses, identify the claim, find the critical values from the appropriate table, compute the test value, make your decision. Okay. And again, if I go back to the tables again, I want to find the degrees of freedom here. Tells us degrees of freedom n-1. So our degrees of freedom here equals, there's 5 matched pairs, so 5 minus 1. Degrees of freedom is 4. At a 0.05 level of significance, this is right-tailed. So we're using the positive value, not the negative one. Degrees of freedom is 4, 0.05. Let's look. Degrees of freedom t-test, right? Degrees of freedom 4. Right-tailed, degrees of freedom 4, right, 0.05, where is it? 0.05 right here, one-tailed. 2.132, and we use the positive, not the negative, because this is right. Right-tailed, 2.132. 2.132. So our T, why does it keep doing that? Our T critical value is 2.132. If you're visual, let me go down a little bit more. Here's 2.132. There's our test region there. And when we find our test statistic, we're going to see if it's in this region or not. If it's in this region, reject the null hypothesis. It's the same thing, same thing. So our test value, our test statistic T, I'm going to the table. I'm going to the calculator. So first let's find the differences. The difference is 5, 3, 6, 10, negative 6, right? 22 minus 17 is 5. 22 minus 19 is 3. 20 minus 14 is 6. 25 minus 15 is 10. 17 minus 23 is negative 6. Yes, yes, yes. That's what I'm inputting into my calculator. The difference is stat, edit. I should have cleared that. Second memory. Number 4 is clear all lists. Enter. Stat, let's edit. So 5, 3, 6, 10, negative 6. Stat, calculate one variable stats. There we go. So our X bar is 3.6, and our standard deviation, and this is the same for D, right? These are the D's essentially. 5.9414. I get that right? 5.9414. Sample standard deviation. Okay, so this formula here is the average of the D's minus the mean of the differences divided by the standard deviation of the differences divided by the square root of n. So the average is 3.6. Average of the differences minus the mean, we're assuming that to be 0, divided by the standard deviation of the differences. We don't need that hard formula there, even though you could do it if you'd like to, divided by the square root of 5. So this is 3.6 divided by, let's check, 5.9414 divided by square root of 5, 2.6571. So I'm dividing 3.6 divided by 2.6571, 1.35. Well, I'll just say 1.35. Why not? 1.35. That's my test statistic. T equals 1.35. I'm testing that to see if it's in my rejection region. 1.35 is not in this region. It's not greater than 2.132. So we do not reject H sub 0 at this level. Do not reject the null hypothesis.